longest consecutive sequence. So we are given a input array, nums, and our task is to find the longest consecutive sequence, which means it has to be increasing, right? So something like 0, 0, 1 would not be a consecutive sequence. However, 1, 2, or like 0, 1, 2, this is a consecutive sequence, right? So and there could be duplicates, so we need to essentially ignore the duplicates. Like this one, this is going to be, the longest would be 2, even though there is duplicates, because we're only counting this part, right? So that's the idea. The question mentions that we need to do it in O of n time, but we'll explore both two different ways of solving this. One is going to be O n log n, and the other one is going to be O of n. So the first way would be to initially sort the nums, right? So arrays dot sort nums, and we're gonna iterate through the array. So first we're gonna maintain a global variable, and we're setting it to 1 because every time we start at an index, it's gonna be, the element at the index is gonna be 1. So that's a count of 1, right? It's not gonna start at 0. So, and we're gonna maintain another variable named current, right? So current equals 1 for and I equals 1, I less than nums dot length I plus plus, and if nums I equals nums I minus 1 plus 1, only then we're gonna increment the count of this variable, right? And then else if we are at if the same number as before, or else if it's not the same number as before, it's gonna be a we're gonna start over. We're gonna maximize this. Like we're gonna math.max answer and then current, and then we're gonna reset this to 1. And there's one more edge case. If nums.length equals 0, then we have to return 0. So at the end, so we need to check this thing one more time, because that's just how it works, right? Like we're only checking and resetting if this is the case, right? So at the end, like when the loop ends, this is not gonna run. So we need to do it like one last time. Math.max answer current return answer. So the overall time complexity is gonna be n log n because of this line right here, and the space complexity is just gonna be O of 1 because we're not using any space, we're just sorting it. So let's run this. Okay, so the other way is we are going to maintain a hash set and we are gonna we're gonna add numbers to the hash set initially. So for int num in nums set dot add num, and we're gonna iterate through the hash set and not the nums, because we don't we're gonna have something like this 3 2 3. We don't want to do this 2 different times. We only have to do it once, right? So for integer num in set, and if set dot contains, if it doesn't contain num -1, what this essentially is saying is let's say we're at 3 and it should not, the set should not contain 2, because that's not the start, that's not going to be a start of the sequence. The start of that sequence is going to be 2, right? If there is 3 and then there's 2 present, the start of the sequence is going to be 2 3 something else. So we don't have to do that repeatedly. That's the reason why we're doing this. If the set does not contain num -1, we're going to do so we're going to initialize int current equals 1, and then while and then we're gonna have to create a copy of the num, right? Because we can't use this to increment, right? So number equals num while set dot contains plus plus number, current plus plus, and here we had to do answer equals math.max answer and then current, right? So and we got to return answer. And this algorithm has a time complexity of O of n because we're not sorting. It's just one iteration. We're sacrificing memory for time. So this is going to be a O of n time and then O of n space, because we're using a hash set, right, for the nums. So those are the 2 different ways you could solve this problem.